Okay, good morning. We now get to focus on learning trigonometry. Okay, so I previewed this a little bit for you with Pythagorean's theorem. Trig functions basically are where we're using the sides of a right triangle to either find the angle or the sides. Okay, there are three trig functions that you will be using throughout the rest of this unit. The first trig function is called sine. Okay, it's spelled S-I-N-E, but the way you pronounce it is you pronounce it like the word sign, like a stop sign. Okay, it's not sin, but sine. Okay, the next one is cosine. It is spelled C-O-S-I-N-E, but we pronounce it as cosine. And the last trig function is called tangent. And we pronounce it like this, tan and then gent. So I want to make sure that you can pronounce them correctly. So if you're asking for help with a different teacher, that you don't sound like you don't know what you're talking about, okay? Whenever we're referring to an angle and you're using trig, they will use the Greek letter theta. So it looks like an O with a line through it, okay? Anytime you see this, that means that we do not know the measurement of the angle. Instead of using x or any other variable like we normally do in math, when we're using trig functions, they like to use this letter, okay, theta. And that's all it is. It represents an angle that you do not know. So in order to be able to solve or use trig functions, a lot of math teachers use this little saying, okay? Is the way you pronounce it is so ka toa. So it's a way that you remember how to set up and solve for each one of your functions. So the first letter in each one of these sayings, say the S here, the C here, and the T here, they all represent the sine, cosine, and tangent functions, okay? So what you're going to be doing today is you're going to learn how to set up your trig ratios, okay? So you're going to be dealing with a right triangle, which you see over here in the picture. Notice here that they're using the theta. That means we're representing an angle that is not given. They didn't tell me the measurement of the angle that's given down here. So we're calling that angle theta. Now, whenever you set up your sine, cosine, or tangent, you're always using one of the angles. It's very rare, if not impossible, for you to ever use the right angle. You will never use the angle. You will never be looking at it from the point of view of the right angle. So we're either going to be using this acute angle or you'll be using this acute angle. Okay? So we're always going to be looking at the triangle from the perspective of one of these angles. That's one of the most important things that you're looking at here. Now, we're going to focus on the angle down here. Notice that they made the angle into a little person, because it's all about looking at each one of the sides of the triangle from the perspective of the angle. So we're going to pretend that you're standing right here, okay? If I'm standing right here from the perspective of angle theta, okay, this is how you would set up your sine, cosine, and tangent functions, okay? So your angle will not always be on the bottom. I want to make sure to emphasize that, okay? It just depends on what your triangle looks like. So sine of this angle is opposite, which is where you get the O, opposite leg, over the hypotenuse leg, which is where we get the H. So when you remember SOHCAHTOA, just the so part is for the sine. Notice, sine starts with an S, opposite is the O, hypotenuse is the H. This is what we use to help us determine how to set this up. Now when you look at this on the next page, you're going to have numbers, and I'm going to be asking you to write a ratio or a fraction to represent the sine of theta. So if you're looking at it from the perspective of theta down here, opposite is the side that if you drew a line from that angle, what side would you touch? That would be this side. So this side of the triangle represents the opposite side. Hypotenuse is always the diagonal side. And remember, we talked about this when we did Pythagorean's theorem. The hypotenuse is always across from your right angle. So whatever the measurement of the hypotenuse was, let's say it was 12, and the opposite was maybe 7, okay? Then if I was going to set up the sine ratio, looking at it from this angle down here where you see the little stick figure, okay? Opposite would be 7 because that is the length of that side. And then hypotenuse, the length of the hypotenuse is 12. So I would say 7 over 12 represents the sine of theta. Okay? This is a ratio. A ratio is simply a fraction, or of course you could write it in another notation using colons. I could say 2 colon 3. That's also a ratio. But for the purpose of trig functions, we're going to use fractions. So if they ask you to set up a ratio using sine, you will always do opposite divided by hypotenuse. And that is how my ratio will look. Okay? Now these numbers that I put in here, 7 and 12, I just made those up so that you would understand what this ratio looks like. When they say opposite over hypotenuse, you're going to get the measurement of the side that's opposite, 7, and the measurement of the hypotenuse of the triangle, 12. Okay? So let me add a side down here beside adjacent, so we have a number down here for adjacent too. So I'll say 7. Okay. So the cosine, which is the part of SOHCAHTOA, cosine is adjacent over hypotenuse. So notice the A for adjacent and the H for hypotenuse. That's how we get the part of SOHCAHTOA. Okay? Remember, this is just a mnemonic device that helps you remember this, because they're not going to give you these formulas. You have to remember that. Okay? So, looking at the perspective from my little stick figure, remember when we talked about adjacent angles earlier this year? Adjacent means that it's right next to. So there are actually 2 sides that are right next to my angle, but notice that one of them has been identified as the hypotenuse. So that only leaves this bottom side to be the adjacent side. Adjacent simply means right next to. So you have to be able to identify opposite, the one across from, and adjacent, the one that's touching that angle. So if I was to set up my ratio for cosine of theta, I would write cosine of theta equals, what is the length of the adjacent leg to theta? 6. So I will put 6 first, because that has to go on the top, over the hypotenuse, which is always the diagonal side, so that is 12. So the cosine of theta equals 6 divided by 12. Now when you have a ratio like this that can be simplified, you have to simplify it. So simplify just means to divide the top and the bottom by the same number, or you can use your calculator and you can just type in 6 divided by 12, which is going to give you 1/2. So if I rewrite this simplifying it, I will have cosine of theta equals 1/2. And we just simplified this fraction. 6 over 12 simplifies to 1/2. That's where we got this from. Okay? And that's it. That's all I'm asking you to do today, is to set up your ratios. Now let's look at the last trig function, which is called the tangent. The tangent, TOA, represents the TOA part of SOHCAHTOA. Okay? So tangent equals O, every time you see it, is opposite, and A is adjacent. So we have to find the side that is opposite and adjacent. So if we look at our picture, and remember, we're always looking from the perspective of theta, because theta is down here. Okay? So what is the length of the side that is opposite theta? 7. So when I set up this one, I would say tangent of theta equals the opposite length, which is 7, over the adjacent length, which is 6. This side is adjacent or right next to the angle. So that's 6. Okay? And that's it. So you're going to do some examples on the other side where I'm going to ask you to set up your sine, cosine, and tangent. Notice that you're not solving anything here. This is just the introduction, okay? You're not finding the measurement of the angle, you're not finding theta, and you're not finding the length of any of the sides. You're just setting up your trig ratios, okay? So let's look at the other side and we'll do the first examples. Alright, so this time you're going to find, these are the directions up here. You're going to find the sine, the cosine, and the tangent. And notice the directions say, just write the ratio. Okay? So you're not solving anything. Alright, so let me move my little screen down so we can see what's going on here. Alright, so number 1. Alright, they gave me my triangle. I see that I have a right angle over here, and I see the diagonal side is right here. Remember, the diagonal side automatically gives you the hypotenuse. So I'm going to label that H so that anytime I see hypotenuse over here, I know I have to use the number 37. Okay, because that represents the hypotenuse. Now, notice that the little guy is standing down here, or theta, because you're not always going to see a picture of a little dude on your paper when you're doing your homework, okay? So wherever you see theta, that is where your angle, that's the perspective that you're looking from. So we're standing right next to this angle. What side would be opposite this angle? An easy way is to just draw a line. This is the opposite side, so I would put an O over here. Okay? And by default, if this is H and this is O, then I know this side is adjacent. It is the side that is closest to my angle, but it is not the hypotenuse. Alright, so now that we have identified the hypotenuse, which side is opposite, and which side is adjacent, we can now set up each one of our trig ratios, okay? So we're going to keep sine of theta, this side always stays the same, equals, now what number should go on the top of this fraction if we're using opposite? 35, correct. So 35 will go at the top because that is the side that is opposite theta. Alright, what number would go on the bottom? Correct, 37. And that's it. 35 over 37. Now you do have to make sure that this fraction is simplified. So if you don't know if it's simplified, you can just put it in your calculator. Do 35 divided by 37. You get a decimal, hit math, the math button on your calculator, which is under your green button, and hit enter 2 times. If you get back the same fraction that you started out with, then you know this fraction is already simplified, and we're done. So we have done the sine of theta. Alright, now we need to set up the cosine. So cosine of theta equals Now I need to do the side that is adjacent. So what number represents the adjacent side? 12. Very good. Over what number represents the hypotenuse? 37. Very good. So 37 goes on the bottom. Now you can use your calculator. We're going to make sure that just the fraction is simplified. So 12 divided by 37. Hit math and enter 2 times. We get back the same fraction. So this is the ratio for that trig function, cosine. Alright, now we're going to set up and do tangent. So tangent of theta equals opposite over adjacent. So which one was opposite? 35. Over what side was adjacent? 12. Alright, we need to make sure this fraction is simplified. So 35 divided by 12, and math, enter. I get back the same fraction, so I know that this is the tangent ratio. And that's it as far as what I'm asking you to do in this section. Okay, so I would like for you to try number 2. Ms. Hall, you can pause the video to allow them to be able to set up number 2 and to solve it. Remember, you are just setting up your trig ratios. Okay, so I hope that you really tried to set these up by yourself and you really made an attempt, because this is the majority of your CDA. Using sine, cosine, and tangent. Either setting up the ratio, using Pythagorean's theorem to find a missing side, or using these functions to find a missing angle. So this is very important, and I think if you have gotten this concept, then the rest of this, we have 2 more lessons left in this unit, and they're going to be easy. Okay, so I'm going to circle the theta because this is the perspective that I'm looking at. So everything is based off of this angle right here. Alright, so I'm going to label the hypotenuse. Remember, the hypotenuse is the diagonal. So this is my H, and it has to be the side that is across from your right angle. Alright, now I need to label my opposite side. So I'm going to draw a line from my angle, and the side that I touch, of course, is the opposite side. So this is going to be O, opposite. And that means this side down here is the adjacent side. Alright, so once we figure out what that is, everything else should be easy because you're just plugging in the numbers where they belong. So remember, the way to remember this part, because this will not be given to you like this on your CDA, is so, ka, toa. Okay, so sine is opposite over adjacent, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Alright, let's set it up. So sine of theta equals opposite, which is 8.2, over hypotenuse, which is 24.5. Remember, you have to check this in your calculator and make sure that your fraction is simplified. Alright, now when I put that in my calculator, it gave me 82 over 245. So I'm going to write this, because when you're taking your test, if you do not see 8.2 over 24.5, this may be the answer that you see. And this is why I always tell you to simplify your fraction. Because if I'm looking on the CDA for a ratio that looks like this and I don't see it, then that means my fraction wasn't simplified. So if I don't see this, I'm going to see this, because that is a simplified fraction. Alright, next, cosine. Cosine of theta is adjacent, which is 23.1 because that has the A, adjacent, over hypotenuse, so 24.5. Alright, so they could have 23.1 over 24.5, or let's simplify it in our calculator. So 23.1 divided by 24.5. Hit math and enter. And I see this one as 33 over 35. Okay, so they could have cosine of theta equals 23.1 over 24.5, or if you simplified it in your calculator, you would have gotten this fraction, 33 over 35. Okay, one more time, let's do tangent of theta. So that is opposite. This is the side that has the O, so that's 8.2 over adjacent, which is 23.1. Alright, or let's simplify it. So 8.2 divided by 23.1, and I get 82 over 231. So if you notice, they just moved the decimal back one when they divide it, okay? So either one of these could be my answer, and the reason why we are always simplifying is so that when you're looking on your CDA or on your quiz, if you do not see an answer choice that looks like this, 8.2 over 24.5, then I'm looking for the simplified answer, which is 82 over 245. They will probably always simplify and make sure that their answer has been simplified. So you want to make sure you do the same thing so that you feel confident and you know what you're doing. Okay? That concludes an introduction to our trig functions. That is part 1 of today's lesson.